Let's look at an example of how to write formulas for ionic compounds. And we'll use magnesium bromide as our example. Now, when we write a formula for an ionic compound, the rule that we are trying to follow is that the positive charges and the negative charges must cancel out so that the total charge is 0. Magnesium forms ions with a charge of +2, and bromine forms ions with a charge of -1. We want to know the least number of magnesium ions and bromide ions needed to create a compound with an overall charge of 0. So we're going to model this scenario using these pink Legos with 2 circles on top to represent magnesium with a charge of +2, and these green Legos with 1 circle on top to represent bromide ions with a charge of -1. If I have just one of each ion, I have more positive charges than negative charges. The positive and negative charges do not balance out, so this is not the right combination of ions because we need an overall charge of 0. If I add another negatively charged bromide ion to the model, now the positive and negative charges do balance each other out. This is the right combination of ions because we have an overall charge of 0. So in this model, we have 1 magnesium ion and 2 bromide ions. So let's just confirm that we have the right balance by looking at our total positive charge and our total negative charge. Our 1 magnesium ion has a charge of +2, and 1 times +2 gives us a total positive charge of +2. For the bromide ions, we have 2 ions, each with a charge of -1, and 2 times -1 is -2. +2 and -2 exactly balance each other out, so the total charge is 0. So we do have the right balance of ions here, we just need to know how to write it. The way we write this formula is magnesium bromide with a 2 subscript next to the bromide symbol to indicate that we have 2 bromide ions. We do not write a subscript next to magnesium because we only have 1 magnesium ion. We only need to write a subscript if we have 2 or more of that particular atom. Let's look at another example for writing formulas for ionic compounds. This time we'll do aluminum oxide. And again, remember that we are looking for a formula where the positive and negative charges exactly balance each other out. They must cancel each other out so that the total charge will be 0. For aluminum, aluminum forms ions with a charge of +3, so we will represent that by using these green Legos with 3 circles on top. And oxide ions have a charge of -2, so we will use these red Legos with 2 circles on top to represent those ions. What is the least number of aluminum and oxide ions needed to create a compound with an overall charge of 0? Well, let's start and find out. Here, if I just use one of each kind of ion, you can see I have too many positive charges for the number of negative charges that I have here. So I need more negative charges in my compound. I added another oxide ion, but now I have too many negative charges for the number of positive charges in my ion. So in my compound. So now I'm going to add another aluminum ion. Now I have too many positives and not enough negative charges in my compound, so I will add one more oxide ion, and now my charges exactly balance each other out. In this example, I have 2 aluminum ions and 3 oxide ions. So let's look at the math to make sure that this works out. Remember, I want my total positive charge to equal my total negative charge. My total positive charge comes from the 2 aluminum ions I used. Each aluminum ion has a charge of positive 3. 2 times positive 3 is positive 6. I have a total positive charge of positive 6. For the negative ions, the oxide ions, I used 3 oxide ions, and each oxide ion has a charge of negative 2. 3 times negative 2 is negative 6. I can see that my positive charges exactly cancel out my negative charges. Therefore, this is the correct formula. And I write the formula Al2O3. The subscript 2 indicates that I have 2 aluminum ions. The subscript 3 indicates that I have 3 oxide ions.